Okay. I will give a brief introduction about me. I am Madhukar. I have been in Autodesk for the last 10 years, and my expertise is on Forge, design automation, and Autocad. I support Autocad API and the Forge design automation API to across the worldwide developers. I am based out in India. I'm hosting this session from Bangalore. So it's just a little bit introduction about the pattern of Forge Bootcamp. There are four tutorials, 4 days, and we have parallel tracks on Forge in .NET and Node.js. As of today, my colleague Adam is taking another session on .NET, and I taking a session on Node.js. And in each day, there will be 4 sessions with the breaks in between. You can submit the question and we will answer them. During the session, we code and you code with us. And as I said, these sessions are all recorded and they will be published after the event. So this is the last day of the week. On Monday, we had a session on viewer. On Tuesday, we have a session on accessing design in Forge, ACC, BIM 360 and other. And on Wednesday, we have a session on dashboards, that is customizing the viewer, inquiring the design data and adding dashboards. And today is the day on understanding how to modify your designs with design automation services. Sorry. I'll be sharing this link in the chat. We will be following this tutorial. Please bookmark this tutorial and we will be following this tutorial throughout this session. The goal for the day is we will be developing a web application that will modify parameters of a model based on the choice of engine you select. If it is an Autocad, we will be modifying the parameters of a block. If it is a Revit, it's a window. If it is an Inventor, it's a 3D box. So based on, we will be updating the width and height, and we will be seeing how the results from the server interacts with our client. Not only this, we will also understand the nuance of web development as we go through to the slides and to the discussion. The first session will be of an hour. I will be talking about the introduction and the basic setup of design automation. And after that, we have a break for 30 minutes. And after that, we will be starting how to set up a server and how to create UI of our web application. In the sessions 3, we will be preparing a plugin and we'll create an app bundle. In this session, we will be not going in detail of how to prepare plugin, but for this session, we'll be using a ready-made plugin that's available on our website. On the session 4, we will be creating an activity and we will be executing a work item to run that activity. And after that, we'll have a break and end of the day. All these times are in GMT. So let's begin session 1, that's intro. And let's understand design automation. Design automation provides ability to use the core APIs of your favorite CAD engine. in the cloud, leveraging the scale of Forge platform to run automated jobs. If you are coming from a desktop developer background, you might have already aware of Autodesk's core products. And if you have developed an application to automate uh, tedious tasks using a desktop technology, you'll be able to use the same logic use it on cloud. We can offload that processing to the Forge platform, which can process the jobs at much greater scale and efficiency. We have 4 engines: design automation for Autocad, design automation for 3ds Max, design automation for Inventor, and design automation for Revit. So design automation for Autocad, you can use this API. Some of the use cases of design automation for Autocad is creating a new drawing file, or querying for information in existing drawing files, cleaning the drawing like doing a purge, or translating text from one language to the other language. Or you can build an interface that just checks the standards, whether the drawing is pertaining to one particular standards. Suppose imagine you have thousands and thousands drawings stored in some cloud storage. As of today, without design automation, you have to download, you have to open an AutoCAD, you have to do your task, and have to re-upload it. Such tedious tasks can be easily done using design automation service, which is a cloud and which is a web solution, which can be easily integrated into existing solution. So overview, sorry. So this is about design automation AutoCAD, and we have a design automation with Max. Design automation API for Max script offers the rich capabilities for 3D data modeling, animation, rendering, and simulation. Whether you are working with 3ds Max or any other format, 3ds Max engine can be used to load and import data from a wide range of sources. Upload or use your own C++ or Max script or Python plugin and implement logic that converts to all parts of 3ds Max architecture. You can perform rendering, simulation, and other compute-intensive operations using design automation for Max. The next is design automation for Inventor. You can run add-ins and iLogic with IAM and IPT files. Full access to the Inventor API is available. That is Inventor Server API only. Some of the use cases using design automation for Inventor are modifying the parameters or features in an Inventor part file, or configuring components in Inventor assembly file, or updating and fine-tuning drawing files or Inventor drawing files. These are some of the use cases for Inventor. And let's see some of the use cases of Revit. Revit engine running in the cloud as a Forge. When we say design automation for Revit, we have plugged the Revit engine which runs on our cloud server as a Forge service. You can create, extract, or modify data. Full access to the Revit database API is available at your disposal. Some of the use cases: creating custom Revit family, automating model creation, exploring and analyzing the model data. Let's understand architecture. This is a Forge service design automation, and this is your mobile application or a desktop application or website that makes a REST calls. Design automation API are in a REST. So only the REST protocol, only the HTTP protocol design automation can understand. No other protocol cannot, not any other protocol. And through REST call, you'll call design automation based on the engine. Based on the engine you choose, the calls will be segregated and distributed to the respective engines on our background. So we have Inventor, we have Inventor API, Inventor Server, Autocad API, Autocad Server, Revit API, and Revit Server. You can see this my code. This is your business logic that you would like to implement, which we will execute your logic. when you upload it to the Forge Design Automation server. Now we understood the architecture, but let's understand how it works under the hood. So you as a developer, you need to make sure the source data is available, and a Forge app code, that is your custom logic code that you want to run against any of the source data that will allow us to execute on behalf of you. Then this will give different outputs based on your instructions. A data could be generated reports, or it can generate outputs, derivative outputs like IFs and PDF, or it can just modify the existing source data. So you as a developer, you need to make the data available in the cloud. Design automation is a cloud storage agnostic. For the matter, it doesn't care where your data is, as long as the data is can be communicated over HTTP. Your data can be on a cloud storage, or your data can be sitting behind a server. We don't really bother. Once you make the data available in the cloud, you need to send those links of your data to Forge Design Automation. If the data is hiding behind some authorization, you need to send those permissions as well. Once we receive the links of your data, we download the inputs via web request, and we will run your code. In the previous slide, I have shown where you will be uploading the design data as well as the application code. This is the code that we will be running against your design data. Once we process the design data using your code, we will be sent back the results to the links which you have shared in the first place, and we'll send back to the cloud storage service. Throughout this process, we process and we just discard. So we will not store any of your information once the completion of work item is done. So I have used a word called work item. I'll be explaining what is this work item in the subsequent slides. So let's create a Forge account and create an app. So if you have already Forge account, so let's go to forgeautodesk.com and sign in. I already have created an account, so I'll be using my Gmail address. Sign in. So it is a 2F code. Use another method, send code. Okay. So go here. Once you create an account, go to My Apps, create an app. Let me call a Forge Bootcamp September 2022. Sorry, not Forge, September, April. We did in September last year. This app is created for Bootcamp. Strictly speaking, we do not need any callback URL for design automation. Since for design automation uses two-legged authorization, we don't need a callback URL. But this app gonna ask us, because here it's not an optional, so we will give some value. So we are using a local host and a port number 3000. You can ignore and you can just click on the create app. So take a note of this. I'm just opening a sticky note. And I'll copy here so that I can be using later. This is client ID and client secret. You need not, ideally this client secret you should not be sharing with anyone. And this is unique, that is for you when you create an app. So, okay, now we have created, let's go back to the PPT. Okay, now we have created an app. The next slide is, so as I said that you don't need an Autocad or Inventor, etc. This is you don't need an Autocad, Inventor, Revit, or 3ds Max. We will be providing the plugin for you. Next is installing the environment, Node environment, and Visual Studio Code, and we need Ngrok. So you please, you can let me show you. I have already downloaded Node.js. So you can go to this website, click Node.js, and download LTS. I have already installed it on my machine. And another thing is Visual Studio Code, and download this. I have installed already this. And another thing is Ngrok. Just search for Ngrok. You go here. Click on the download button. You can install with Choco if you have a Choco, or you can also install as a zip file, download it. Then after that, after installing Node.js, the next thing you need to install Visual Studio Code. After that, you need to run Ngrok. So you can see after installing it, you can check to check Node. I can call Node -v. It gives a version name, and you can call code. Code is a Visual Studio Code. When you run code -h, it will show that Visual Studio Code has been installed. The next is Ngrok. You can just run Ngrok. It shows that Ngrok has also installed. So coming back here, close this. Come here. So okay, Ngrok download demo. I think we have some time to start session 2. So I will give ample of time. We have time till it's 2:30. So you have time till 9:30. 9:30 to do these installations. Please do and let me know. I will be available. I am pausing the recording for now and share. Okay, the session is now recorded for the session 2. So in this session, in the second session, we will, can you please let me know if you are able to succeeded in installing Visual Studio Code, Node.js, and Ngrok? Maybe you can ping me in the chat. Hope I believe that you have already installed those 3 tools. So we will be going forward. Thank you very much. Okay. So let's understand our web architecture that we will be using to develop an application that consumes the 4 services. So if you are new to the web development, this will be the good point to understand the big picture, how what role each plays in developing a web application. So we have something called client side, that is your web browser or mobile application or a desktop application. And we have something called server. Server is the secret sauce or the code where you write your business logic, and the client is the one where you see the browser. The browser can understand only the HTML, JavaScript, and the CSS, that whatever it will be, whatever the files it has been redirected, the browser will be rendering that. So the browser is a client, it only knows these 3 sorts of files and just renders them. So the server is the main crucial thing where we encapsulate the business logic. And we have different services in Forge based on the behavior of first 4 services, and the accessing the services can be from server and can be from the client. So for example, if you have attended in the yesterday's call, my colleague might have talked about your dashboards. So that's a client-side framework where you don't need a server at all. So only you maybe need a server for getting authorization, but it's a client-side framework. So you'll be rendering the viewer code on your web browser. But when coming back to design automation requires design automation is a server-side access service. So what you do is you use client-side to build your UI, and from UI you'll be raising a request to the server. In server, there is something called a middleware, which is a pipeline between the client and the server that will process your requests. So it will listen to the request and it will propagate the request to the endpoint that is listening, and it will send the response back upon receiving the request to the client. So that's the role of this middleware or web framework that we will be using in the subsequent slides. So from the server side, we will be communicating with the Forge service. In this session, in this class, we will be communicating with the design automation. From client side, you cannot call design automation API directly. There is a way to directly call from client side. For that, you need to use WebSocket. That's API from design automation, but in this session we will be not talking about the WebSockets, design automation WebSocket endpoint, but we will be talking about the technical nature of the WebSocket that allows us bidirectional communication between the server and the client side. So let me walk through in a simple example so that you'll be able to understand it. So let me pick a pen. So you as a client, you developed a UI. Let's take you have a button. You created a button. This is your client. When you open a browser, you'll have a web application, and let's understand this UI. You have a box. You have a button. When you click on the button, when you click a button has certain callbacks. What to do when you click on when it releases a click event. So what we do is from the client side, from the HTML, upon listening the click event, we will be calling an endpoint that server has exposed. That endpoint is simply nothing but get engines. Forge application. Forge design automation application has an API called get engines. In the previous slides, we have seen that design automation has the 4 engines like Revit, Autocad, Inventor, and Max. So we created a button, and this button name is a get engines. And when you click in the click event, we will be calling an endpoint. That endpoint is residing on the server. That endpoint name is get engines, and this get engines in turn will call the Forge API. So this server will be calling design automation service. And when you call the get engines, you'll get a response. You'll get a response on the server, and the server has to broadcast that information back to the client. That broadcasting happens over the REST, or that broadcast happen over a middleware. So in this application, we will be using something called Express framework. We will be seeing what is the role it plays. So you click a button. The button will send an event. It will listen to the event. In the event body, we'll be calling a server endpoint. This server will expose an endpoint, get engines, and this get engines in the body of the get engine on the server side, we'll be calling actual design automation API, and the design automation API will be sending a response upon listening to the request. And this response we need to broadcast back to the client, because client we are waiting it here. And if you draw another box, something, it's just some text, you'll get a list of all these engines. So this is the mechanism in nutshell. We will be using this mechanism in our web application. Okay, now we'll be initializing an Npm project. I'll be coding 1 to 6 steps. After that, you'll have some time, or else you can also code along with me. So let's see what all we'll be doing. We'll be initializing an Npm project, and we'll install the dependencies. We'll be using a VS Code, and we'll configure the VS Code to help debug, build, debug, and publish, launch the application. And we'll also prepare a configuration data to use in our application. This configuration data will have client credentials that we have saved when we created the first and the fourth application. And the next step, we have something called start.js. This is another file. We'll be writing it that will create a basic server. We are using Express, which is a modular web framework, which is the standard web framework, de facto standard web framework for Node.js. And this will create that the middleware pipeline where routing will happen. The routing transition will happen smoothly. And we also create a router using the Express framework for authenticating endpoints. And we'll also set up a basic UI. So let's start. So next is the demo. So is my screen visible to you, or if you need me to increase the font size or something, let me know. I will be using my command line, and I'm more comfortable in command line, but you can use anyway. So I already will be following this tutorial. So create server. Create server. So the first things first, we need to check if Ngrok is working at your end. So what you're gonna do is, I'm gonna create another shell. So I'm gonna just run this in Ngrok. So it's running this. So because I will be needing this URL in the subsequent slides. So it's running it. Maybe you have to also run this at your end. And please bookmark this one. We'll be following exact this tutorial as it is. So I will be explaining it, why we are using Ngrok, what is the need. So why we need Ngrok? What is the use of this tool? Do we need it? Is design automation really dependent on this tool? Can't we get away with this tool? Yes, this is one of the options in many of the alternates we have. And Ngrok is required when you're developing and debugging application in the development mode. That is, your application is not published into the production environment. And why we need Ngrok is design automation is a server, and your application is developed on local host. Design automation cannot reach to your local host because local host is not published to the public network. Your local host is not visible. So what we do is we need to do tunneling. Ngrok does that. What it will do is it will tunnel your local host and it will expose your local host to the public environment. So you can just access. You can call this. Let me stop here and let me go to some temp directory so that. Okay. Ngrok. Yeah. Oops, sorry. I need to copy this. So you can access this. I'm just pasting in the chat. So you can just click on it and let's see what happens. See, now I'm opening an edge. And when I run this link, so okay, I need to start a server. So let's what we do is okay, now let's come back here. You can see all my directory listing it. If you click on your website, on your side also, you'll be able to see all this. So I'm closing this because it's a completely my user folder. So let me close this. So let me close this and let me. Okay. So now you understood, right? Just clicking on the local host, Design Automation cannot reach to our local computer. So to make our computer reach to Design Automation during developing, not in the production, we need to tunnel, so that we need some utility that can expose this local host to the Design Automation. Why we need this is because we are using something called WebSockets. The WebSockets need, when Design Automation completes certain progress, that has to reach to our client. So for that, what further we will send a callback URL. So we are going to send this webhook URL to Design Automation on complete endpoint, So whatever the progress the Design Automation is doing, it will send the messages to this URL. Since we are listening to this URL using the WebSocket technology, our client will be, the messages will be broadcasted back to the client. So you'll be understanding a little bit, but the main reason for Ngrok is to open up your local host so Design Automation can really reach to your local computer. This is one way to do that. And make sure this only you should be doing on the development when you're developing, not in the production, because easily you'll be revealing your local folders to the entire world, which I did just now. So let's come back. The first things first. So we're done with that, and set up project, choose the language Node.js. So let's create a project name called Forge Sample. It says that Forge Sample. Please, when you're creating a new root folder or new project folder, make it simple. Make it avoid having spaces, and use as far as lowercase. So I'm creating M directory. So Forge Sample. Okay, and change to Forge Sample. Okay, next I need to np init. So it's empty np init. Okay, yes. Blah. Here you need to enter start.js. This will be our entry point. Test command, nothing. We don't have get repository, keywords, nothing. Author, you can give your name. I'm giving my name. License MIT. It can be anything. Yes. Oh yes. So we created a package.json, and this has this information which have already typed. So next we need to install npm. So I'm installing the first Express. Npm install Express. Save. We are using this save parameter while installing Express, so that it will be saved under the dependency in your package content XML. So package.json. So this has installed. So like that, we need to install everything. But what I'm going to do is I'm going to copy this. I'm going to do npm batch. So you can open this code dot. When you run a code dot, the Visual Studio gets pop up. Open this and space this. What it will do is control H. So I'll find for npm. This is just a simple trick. to install everything at a time. Save this, close this, come back and run npm patch. Oh, what does it happen? Okay, don't follow this. I think something screwed up. Something happened bad. I don't know what happened. Let me uninstall. Oh, oh, sorry. I named it as npm, and when I run npm, that batch is getting called, and it became a test. So okay, and we need to see ls depth 0. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So we have installed all this 4JPS cookie, but you can install individual at a time, whatever the better you'll feel. So I think I have all have been installed. So the next thing is I will open this in the code, in Visual Code, and go to package dot. Okay, we need to add a start.js. Final open, insert the scripts, add start node.js. Okay. So this looks okay. We added this. This is just a spell error. You can ignore. And we've done this. Now we need to create different folders. We are creating a routes folder for all server-side files and a public folder for all clients. So we need to create 2 folders. So we can create directory public and routes. So we have 2 folders, public and routes. Next, we need to add launcher. We need to add configuration. So we'll come here, add configuration, pick up the Node.js. So what I do this, come back here and just copy this. And now this is where you need to fill up your client ID, client secret, and webhook URL. So we saved it somewhere in sticky notes. So just copy this and put it here. Copy this and put it here. And we need a webhook URL. So this is this. Make sure you copy HTTP1. Okay, this looks good. This looks good. Now come back. So what does it says? Okay. Now we need to create a start.js file. Let's we don't need this anymore. Come back here and create a start.js file. So we have a start.js file. So as I said, the start.js file is the one where we will be creating a Express server. This will be creating and starting an Express server. And make sure the file names be case sensitive, and try to use some applications, some deployment platforms like Heroku are very case sensitive. So try to use a lowercase and avoid spaces when you create a new file names. So I'm going with start.js. So let's copy, like we need to call the server.js, and we need to call socket.js. We'll be filling up these files as well. So let me copy this, and I will be explaining it each step what we are doing it here. We need to create another JS called server.js, and we need to create a socket.io.js. We have not yet created. This socket IO, why we need socket IO is this socket IO uses socket IO will help you to establish a bidirectional low latency connection between the client and the server using the WebSocket technology that uses WebSockets. So we need this because we want this will help us in preventing the constant polling the design automation server. For a new information, you need to poll the API, design automation API, which is very bad and redundant, and it's harming the servers. So what we need to do is we need to establish a WebSocket connection between the server and the client. Whenever, since design automation also exposes a callback URL, that is on complete, on progress. These are the two endpoints or callback endpoints, or what we call as webhooks in the web technology terminology. Design automation, we will be leveraging that on complete callback. So WebSocket will be listening to that webhook, and that responses will be broadcasting back to the client. So this broadcasting will be done on this framework called Socket.io. So we are listening on the 3000 port, and whatever the information will come, will just back. We will just back it to the client. That's why we are writing console log. This start.js is sitting on the client side. Okay, and this goes on the server side. Whatever the files that goes in the public will be on the client side. Pardon me. Okay, next, after this, now we need to create a server.js. Let me copy this. So now why there is a return statement here? Okay. You may get that error return statement. You can easily remove that. Okay. Okay, so here we were here in the server, the server.js. This is the file that serves the static files, and even this will manage the routing the API requests. So this line will serve the static file. All the files that is residing in public folder will be served by this server.js, and moreover, this also help us in the routing the API. So we have created an endpoint API. In the coming another file will be showing the body of this endpoint, what this endpoint does. So when you call this API, we'll be calling this endpoint actually. So This is the API that client will be calling, and the definition of this API will be in this JavaScript file, the design automation.js that will be routing, will be writing, and we are listening on the 3000 port. Next, after server, we need to create a socket io.js. So these are all. Let me close this. That's socket.io.js. So if you look at socket.io.js, this is a file that will be using socket.io framework. So in start, we are listening to the socket.io. We are listening to the socket.io. Here, we will be doing the things upon listening to the connection. Whenever the connection happens, so whenever it happens on the connection, we'll say the client is connected, and we'll say client is disconnected when we will listen to the disconnect. Okay, next, and config file. This is this. Let me write it. So touch config. So let's get back to here and config. So this config will be managing the client credentials. We have this. Okay, in little bit this can be empty also. We are not be using any callback URL here. We'll be using the webhook URL, and we'll be also writing the scopes. The important thing is the design automation requires only this scope, that code.all. And these scopes are required if you are interacting with the data that is hosted in the OSS, Object Storage Services, or in the BIM 360 or in the ACC. And this scope is required to access the viewables that by the client. So we'll be generating two type of tokens. One is internal token, that will be, the token will be used to authorize between the server and the service. Service means the forge. And the public token, that token authorization will be used to communicate from the client side, that is from your web browser, to the forge service. And we have something called a backup delay and backup policy. So the idea behind this backup delay and backup policy, which is an exponential backup with jitter something, is to exponential backup is to retry instead of retrying after certain waiting time, is to increase the waiting time between the retries after each retry failure. So that waiting between the retries will be exponentially increased. So that we will not be abusing the servers. Of course, we may get a 404. So what we'll do is we will give certain time and we will retry again. So instead of repeatedly retrying, so the time interval between the subsequent requests will be increased exponentially, and that is what we are telling here in this configuration file. And after 13,000 milliseconds, we will just send a request timeout. These are the basic facets when you're writing a server. The next, and we need to create we already create a folder, and we need to create another folder and auth.js. So let me create that as well. Same directory to routes. Make directory common. Common and touch. Okay, we have completed this. So come back here now. Oops, it's did something wrong. It should be okay. Okay. So we are adding the file here. So this is the API SDK for Force Design Automation. No, this is an SDK for the Forge APIs. This contains authorization, this contains a derivative, and this also contains basically derivatives and object storage services. Next, we are plugging the config. Okay, yes, that's correct. And here we are getting the client to the internal scope. We'll pass the scopes, and this will be generating the two-legged authorization token. So I will give like you might have already in the first session, you might have known what is this authorization token and all. There are two types of tokens. That is two types of authorization. That is a two-legged and a three-legged. Two-legged is the simplest authorization. And before two-legged, there is another type of authorization called bearer authorization. But anyway, we are not using that anymore. Two-legged authorization is simple that where only two guys are involved. That is your service and you, and the service will be giving you the client ID and secret. You'll use that client and secret, and you use the a two-legged grant, or what you call it, a special size grant that will create an authorization token for you. The next is three-legged authorization token, or three-legged token, where you have the service guy, you, and there is other person whose data you're accessing, your customer. Maybe it's you as a developer developing an application, you're using the Forge services, and the customer comes to your application. Now you want to access his data, and for that, the third guy is that person, and we will be using the three-legged token for the different Forge services like BIM 360 or ACC or model derivative for that matter. But design automation, really, we don't need a three-legged token at all. So this JavaScript file will be using to develop using to create a token. Okay, the project is ready. At this point, it should look like this. So okay, let me see. Yeah, it looks like that. Package.json, server socket OA. Okay, fine. The next is building the basic app. The UI is based on a simple vanilla JavaScript and HTML file, and the WebSocket implementation is uses the socket.io. Okay. I'm sorry whether I'm sharing my screen. Okay. Oh. Thanks. So we developed the auth. Now we will be back to developing the basic app. So we'll be using a Node.js. So under the public folder, we'll need to create index.html. So we need to come out this, come back to the public, create index.html. So let's copy this and okay. This should be very straightforward. So we are using a jQuery, a vanilla framework to call the API requests, and I don't know why it's error, but I think it will work. So this is a basic template where you'll have this sort of a UI. If we go back and so this is a UI we want to develop. You have a start button and width and height, choose fine, configure it. So that is what we are doing it here. So we need to create another folder JS, and on that we need to create forge design automation.js. So I will be explaining what we are doing it here. So make directory JS. If you come back here, we have something like this. So let me copy this. Okay, so let's see what all we have here. So this is the main JavaScript file that runs the show, that will interact with the client and the server. So this is a client-side JavaScript file that will be calling the APIs on the server. So let me explain one after the one. So this is a normal. It's you have it comes in the configuration. It has clear account, define activity model, app bundle activity, and work item. So and there is a method called start connection. So on the client side here, this is where we actually establish a connection between the client and the server with WebSocket. So the WebSocket, when you run this connect, it will do an initial shakehand that uses still HTTP protocol to make initial shakehand. This internally that will call the HTTP to the server. Once that initial shakehand happens, both the client and server establish the shakehands. Now the communication established bidirectionally, and no longer the protocol is HTTP, but it's completely WebSocket protocol. So that connection we are establishing it here, and we will be listening on a different inputs: download result, download report, incomplete, whatever the message that server broadcasts. A subsequent listening happens here, and we'll just push it to the HTML write log. If you look at this write log, what is this? If you look at this write log, so we are just creating a div element, and in div element we are populating the message. Okay, come back here. The other important thing is, so this jQuery Ajax. So this is the API that we'll use to call the endpoint. URL endpoint. And what is this endpoint? From where it is coming? So list control endpoint. So if you look at this prepare list, the list takes a control and an endpoint. Control and endpoint. control and endpoint. So this function will call this endpoint. This is not API, this is an endpoint. From the endpoint, we will be calling the service API, design automation service API. So we are calling the 3 endpoints. So where are these definitions? It will be in the routes. So we need to come back to the route. So all other methods are also doing this. Even when you click on the start work item, what we'll do, it will start a connection and it will also call this API, this endpoint for design automation work items. Okay. In routes common, there is auth. In the routes, we'll be creating another JavaScript file that will be listening to these endpoints. That is the server side. Now we are still in the client side. Okay, so for even the creativity activity, we're calling this endpoint, and bundle we are calling this endpoint. So that's about this one. So no, PPT setup basic UI. I just completed demo. We created all this. We have initialized a new Npm project. We installed the dependencies. We created a new launch configuration, and we prepared the configuration data. We created the basic server start.js, and we create a router for authenticating the endpoints, and we set up the basic UI. So maybe now we can start. We will start back at 11 a.m. So have a good time. I'm pausing the I'll be pausing the share now and recording as well. I hope you are able to complete the tasks. If you want me to give some more time, like 5 to 10 minutes, it's okay, I can give, or else we can go ahead. Okay, I'm going to the next session. In the session 3, we will be preparing the plugin and app bundle. Of course, we will be not preparing a plugin. We will be securing the plugin from the URL because preparing the plugin for different engines will take a lot of time. For this tutorial, we'll be using the existing plugin and to run our application. So just click on this. Let me copy this. So I'm copying this. So let's go back to the tutorial. Let me explain a little bit. You need to create a plugin when it comes to design automation. It requires 2 sets of skill set. One set is a web development that is generic across any other technology, and another which is very specific to design automation is the knowledge of the API of the respective engine. If you really want to get the best out of design automation, and you need to know the thorough knowledge of the engine which you're using. If you're using Autocad, we expect you to know the Autocad.NET API at least. If it is a Max, Python, C++, etc. If it is Revit, it's again .NET API. If it is Inventor, it's again .NET. So we need to have that knowledge, and the plugin what we design for design automation is not same as the plugin we design for a desktop application. the plugin code that we develop for design automation should be free from the UI code. So since design automation uses the headless versions of respective desktop applications, so there is no concept of UI. So if you have an existing app and you would like to use a design automation, you need to fine tune. Basically, you need to remove all the UI related code. So, and to prepare a since you know how to deploy the plugin on desktop applications, we'll be using something called bundle. That is the same technology that is used for desktop applications. We will also be using the same technology. That plugin will have a package contents.xml, and the package content.xml, if you go, it's a storefront for Autodesk customer to find. We have Autodesk App Store where you can host your apps that can work on Autodesk products. So we'll be using where is this one? Okay, so we'll be package contents. So for Autocad, this should be safe for any other engine as well. So let me search for compare and search for package contents. Okay, so let me copy here that is. So we will understand the basic bundle structure for a plugin, and that will be used for using your plugin code. Again, this plugin is not a mandatory. This plugin is only required if you are writing your own application, because design automation have some public activities. For that you don't need to use plugin, you can straight away use direct activity. But if you want to write the custom activity, you have certain custom logic that you need to process using the design automation, then you need to write your plugin. So the plugin comes in the form of a bundle, dot bundle. It's in a folder. This contains a package dot content XML. This is a manifest. It's a manifest that will tell where is your help file, where is the icon. Of course, these are not required in design automation. So the main thing is the manifestation. It will tell what is a module that needs to be loaded. In this example, we are loading a list file, but it could be anything. It could be .NET, it could be .add-in if it is a Revit, it could be Max script if it is a 3 days max, or it could be simple DLL if it is a Revit. So this is important, and this list file is exposing any comment, even that has to be enclosed in bundle. So at the simple, this is what the bundle structure is. We have a bundle, we have contents where you will have modules, and we'll have some resources. In resources, you can have a template drawing, a template Revit file, etc. You can you can so let me copy this, and you can take a look at later this. So basically, this is the overview. It's a kind of a structure that needs to be uploaded. We will not upload a .bundle folder. What we do is we'll zip it. We'll zip it and upload to the design automation server. So design automation server will unzip and will run your module, whatever the module you have mentioned in the components, that will be run. Suppose if I am using this list, this will be executed. Whatever the command or function that is exposed in this DLL will be exposed. If you have this command, you have to write it here. So for example, let's look at this. It has a list file, it has a list file. Oh, it doesn't have show any commands. Let me show package contents. Bundle. So what we call something an auto loading mechanism. So let me open this. So I will show. So let me take this. Let me take this example. This is a manifest file, and if you look at this is targeting the series minimum and series max. Only these versions of desktop application. In this only versions that this model will be opened. So this ARX file. So design automation for AutoCAD will not understand ARX, but it can understand CRX. ARX is for AutoCAD runtime extension, whereas CRX is console time runtime extension. And for AutoCAD, it's CRX. For Revit, it's simple DLL. And for Inventor, also DLL. But this application exposing two commands, and the two commands needs to be enlisted in this bundle. So when design automation loads your bundle, it will call this application and it will check what are the commands that needs to be executed. If this is a command that you want to be run using your activity. Okay, let me close this, let's come back. So download and logic for creating an app bundle. So let me download. So I'm downloading this. Oh, sorry, I'm downloading copy link address. So let me prepare. Okay, next. So you can choose the engine which you want. I'm choosing AutoCAD. So this has in detail instruction how to create application logic. Now we need to download this into the bundles directory. So we need to see where is this. Okay, so we need to create a www root. We need to create a bundles. We will be downloading it. Let me copy this. So I will just go through it. We will be not creating this plugin now. We'll be using the already existing. But if you are creating an AutoCAD or Inventor, please go through that respective tutorial. So for AutoCAD, it's very straightforward. You need to install the AutoCAD SDK that starts with .NET Core and Model. And in the command logic, it has only one single command. A command that is update parameter that will update the parameters of a block reference. So what we are doing is when we okay, let me come back here. So here we are entering width and height. This information will be passed as a JSON from a client. Will be capturing this information from client and will send it to the server, and that information is passed over as a JSON file. And this command we are here the JSON is serialized, deserialized into input parameters. These input parameters object has width and height. So this is one of the key points we need to understand. So that is how we get the inputs from a user, and we will collect that information what user entered on our server side, basically in the code, in the design automation code, and we'll use that parameters and we'll find what is a block reference, and we'll update the parameters using the values which user has entered, width and height. So this is a code that updates the dynamic properties. So it should be same for other engines as well. If you go to Inventor, Inventor. So come back here again. This you can see that again we are deserializing it, and we are storing the parameters, and here also we are updating it. Param entry key expression value. Here we are updating it. Let's come back here, and if you go to check the Revit, this I keep going to this Revit. The same thing again. You need to install the SDK, design automation SDK. Like AutoCAD for Revit, we have to install the Revit DB. So here also we need to deserialize the input values, and here we are updating the parameters. Revit design automation. I'm assuming that you are well versed with the respective APIs, because in this tutorial I may not be able to explain what each API works, but I'm just showing how it can be written. So let's go back to the AutoCAD, and if you're starting later, I mean, you can go to this tutorial, start a project, and create a simple .NET command for AutoCAD. In that command, get those input values for this application, and this drawing contains a simple block references. So we need to get the access to that block references. The block references will be stored in the model space. Model space is nothing but a block table record. And once you get the block references, we just update the dynamic properties. So this is the whole code. And now this is the interesting part. If you look at the package content XML just now, before I have explained it. So this is the DLL. Once you build that application logic, you'll get a DLL. In this DLL, you're exposing only single command. So let's come back, look at update param. So this is the command that we need to give it here under the component entry. So this is the command that design automation will run, will execute this command. So when it gets execute this command, what are all it checks? It already got the input parameters from a client, so it will just process it. So this is the structure it should be. Now you'll get a bundle. It's important that you zip the bundle, and that zipping the bundle is what will upload it to the design automation server. So now next is the, let's see, what are the next steps? Okay, we need to download the bundle and store it. So okay, prepare the plugin. So we need to create another directory called bundles, and we need to upload it to there. Make a directory bundles. So is this? I'm copying this, copy link address. Okay. Okay, so if you look at Node.js, This is the bundle. So we need to copy in this here like this. So which I already done. Public is the bundles and there is a file. Okay. So let's get back to the PPT. I have already defined the app bundle, and now it's time for you to download the app bundle. So create a folder bundles and download that into the. You need to create a bundles in the root directory and download it to that update. Download it to that up. Place that in a bundles. So if you have questions, you can ask me now. And to develop AutoCAD bundle, to develop bundles, plugins, we need to use Visual Studio. VS Code will not be sufficient if you're using developing applications for AutoCAD, Inventor, Revit, or 3ds Max. You need to have a Visual Studio professional or Visual Studio community. VS Code is good for developing web development. It may not support to develop AutoCAD or Revit applications. So this tutorial is using 4.7, but it's okay, fine. You can install even 4.8 .NET Framework. The interesting part is once we upload your bundle to Design Automation Service, our Design Automation server will unzip it and it will run this code. How it will run this code? Simple like this thing. So let me explain another thing. So Design Automation for AutoCAD is nothing but so we have something called AC Core Console, and this is the what we have in on Design Auto on server. So you can have some drawing file, and you can execute it. And if I run this without any drawing, it will take a template drawing. And I do not have that update param command, so that's why I'm not able to run that. But if you're able to, I think, let me search if I have that source code already. I think I have, right? So let me come here, bundles. Let me, okay. I think I have. Oh, okay, this has been installed. Okay, I think download was okay. So it's there. So what I do is do one thing. Just okay, this has contains everything. Oh, and what do I need? I need a drawing, right? So let me get the drawing. So, okay. Okay, this is a drawing that has a block references. Let me open that in Autocad so you'll understand. So if you look at 20 and 40, so we need to update this. So this is JavaScript. So I also need params JSON. Okay, so what I do is come here. JSON. Okay, so we needed this information. I'm just storing some hard coding the values in parameter JSON. These are the values where user will enter interactively on that web application. So let's see whether it will work. Is a good console. Okay, so if you go console, copy full pipe. Minus I and this bundle param will it ask what is the code? Let me see that. Oh, it should be sorry. So why this command is not working? I think loading has a problem. Okay, what to do? Okay, this is working now. That's good. So what we'll do? Okay, we'll copy. Where is this param JSON? Copy path. So let me run this again. Good, great. So we got output file. So we'll open this. Open. So I think for 23, we need to recompile. That's the reason. This will become very short. So 10 and width has 10, height. Oh, okay, sorry, I need to keep height. So let me change it to width 60, height. So let me close this. What happened? So is going to input parameters, it's width and height. So essentially, yeah, versus correct. Now let me delete the output file drawing. So this is what exactly happens at design automation server also. So we for AutoCAD, for others it will be a little different. So we will be executing this command. Basically, design automation on behalf of you, it will be executing a similar command. We'll be sending an input drawing, and we'll be. I'm using this AL called application load, and that loads your bundle. So when we upload a bundle from your local computer design automation server, that code will be available for our service to access it. So since this is the backend of design automation service which I'm showing you. So we have an input drawing which has a block reference, and we are uploading the application load. And we have written a param.json. This is to mimic what users will enter. If you go here, so here they will enter, right? We want to mimic it because since we have not prepared the application yet, we want to mimic that. So that's why we have created a param.json. So why we created a param.json? If you go to here, select this, the code is reading param.json. So this code is finding for params.json. So we already have that in our, sorry, we already have that. So let me run this. So update param, just save, quit. Okay, that's fine. Now launch AutoCAD 23 or something. Oh, this is interesting. Now we want to see the drawing. If you look at this, the block reference has been, it has come to 60 and 40. So this is a whole game of this automating a block reference using the API instead of doing it locally, but that can be saved replicated locally also. Okay, hope you understood the logic. Let me close all this. Oops. Output file, delete params.json. Okay, we don't need this. We need this guy. We don't need this as well. But so what are we going to do from here? Update. So I'm gonna control X. Park. So okay, now I have saved it. So this is the file. So it's now your turn. If you have any questions, please let me know. I am pausing the share and I'm also pausing the recording. Okay, this is the session 4. Hope you have downloaded the app bundle and placed it under the bundles directory. The next is session 4, define activity and executing the work item. First, we need to create an activity and then we need to execute the work item. Let me explain what is an activity. Activity is an instruction, instruction or a specification which will allows you to submit the inputs, run the command logic and get the outputs. So these are the things that will be encapsulated in the activity. So basically activity is an instructions set, or to put it in programming analogy, it's a function definition. It's a function definition where you have inputs and you'll have a return type with the outputs. It's a function, you'll pass some input, the function will do something on the input and you'll get the outputs. So this the inputs have a certain placeholders. Function will have certain input arguments, and whereas it will also return the output arguments. That is what the role of an activity. And in the body of the function, you'll be doing some logic. So in the activity, you will have input and output, and you'll also have something called a script. That is what design automation is going to do for you on the files you have submitted. So activity is the instruction manifestation that will have set of input parameters and set of output parameters that you will be sending through an work item. The next, when we say a work item, when I say an activity function definition, there should be its counterpart, that is function call. The function call is something which will send the actual values to the actual values. The function definition will have the placeholders, the arguments, whereas the work item will be sending those parameter values. The work item will be sending the links. Suppose you have an input, it will be sending the link of input drawing or input Revit file, and you'll also send the link, storage links, basically storage link of input files and storage links of output file where the processed file should go and reside. That's what executing the work item mean. So let's go back, close this. Now we need to upload the app bundle. So inside a route, inside the route folder, create a design automation JS. So come back here, change the route, touch, come back here. And now this is the file that will be residing on the server side. We have two files. Let me close all this so that it will be easy to understand. One is for design automation, that's the client side, which will be sending the requests or which will be calling the endpoints. But where are the endpoints located? In the router. So this is where the endpoints are located. If you look at T3 routing get client. So 1 second. Copy. So you in this file we'll write all. Okay, we are writing all the utilities functions for all that. Then we need, before creating app bundle, we need to define app bundle with a plugin. So in the same thing, after the util class, so we have a util class. If you look at util class, after this, we need to add this code. So app bundles, this is an endpoint. This endpoint will be in the design automation, and if you look at okay, let me control C and control. So from client side, we are calling this API endpoint, and from here we are listening to that endpoint. Where basically we will receive that request and will process it and will send the response from this routing logic. Next app bundle we copied. So if you look at, we have all the endpoints. One is for app bundles. When you call an app bundles, so when you call this endpoint, what it does is it will find for the local bundles folder. So this local bundles folder, if you look at locals bundles folder. Okay, 1 second. Local bundles for see, path resolve path direct. Then next is engines. This is another endpoint which will give the list of engines, list of engines. So from this endpoint, what we are doing is calling the design automation API, get engines. So API is coming from the design automation SDK. So DAV3 is so this, if you look at, this is the API that that is actually initializing the design automation SDK API. So we will be using this API client to call we'll use this SDK client to call all the APIs on the 4 services, whatever we require from the endpoint. So let me okay, now after the engines, the next one is getting the app bundles. So again, here we are calling the design automation API using the get app bundles. So getting the list of app bundles. This was engines. Now we are calling get app bundles. The next one is uploading the bundle. The bundle which we have copied it here needs to go to the design automation server. So for that, we need to call design automation API that will give us an S3, AWS S3 storage location, to which we will be uploading the zip file. If you look at, we're using upload form data with file, we're uploading this zip file using this method. So that's all for related to the app bundle. Getting the engines, list of the app bundles. Still, this is not completed. We have to add the definitions for the activity and the work item also. So app bundle. Next. Now let's run the app. Now let's run the app. Let's see what will happen. So I'm running this. So if open localhost, so you can see that app. This is the first web application we have created for today. When we run that, you can see the bundle has picked up, and you're also getting the engines because we have configured the get engines API in that endpoint also. And but these buttons will not work. These buttons will not work because we have to yet write the activity. So I'm just closing this. Come back here. This, the client is connected, a client is disconnected. So you can see this information. This is coming from the WebSocket. Next, deferring an activity. So as I said, that it's in a specification of an action or instruction that can be executed by specified engine. So activity will have three main parts. One is the set of inputs and outputs, or what we call as arguments. And another thing is the script, the action, what you want your engines to be do. And another one is the engine which you want to use. So let's put it simple example. Suppose you want to print or plot Autocad drawing into PDF. So for this simple exercise, the activity would be the input. You need an input, a drawing placeholder, output, a placeholder for PDF. In the script, I will be using plot logic, and in engine, I will be using the latest Autocad. So these three important things are required to create an activity. In this tutorial sample, the activity has two inputs. One is file, that is drawing file, other is a JSON data, and you'll get one output file, that is a drawing file, which I have shown just an hour back, doing that in the local. So we need to write the endpoints. We need to write the endpoints for the activity. So just before the model exports to route the router. So now let's look at what are all the endpoints. Okay. So first is activities. This will give a list of activities. So if you look at, we are here, we are preparing the basic activities. It gets the list of activities. And now you need to prepare a activity will have a qualified activity name that follows a nickname, activity name, and alias. This is very important. It's a good practice to create an application name or a nickname to your app. The benefits of creating a nickname for your Forge application is it will make easy to distinguish between one Forge application with other. So it's like naming the folders in a computer that will help you to quickly filter out what each folder has. So it's important that you create a nickname. If you don't create a nickname, Autocad will assign your client as its nickname, and you'll not even understand what does it do. So that's why having a nickname is very important, just like creating a folder name that which will allow you to understand what the contents of its folder by the name. So this is helpful for you for maintenance. Now we are creating the activity ID. We're searching whether activity already exists in the listing get activity. If not, we are creating the activity. So this is a spec. As I said, activity has three important things. One is the set of parameters. If you look at this, set of parameters contain input JSON, output. For this exercise, I'll be needing two inputs and one output. And a script that is the entry point to the Autocad engine. And the next one is the engine definition, where it is engine name. And this command line, when you pick engine, this command line, for each engine, this command line going to vary. We will see what are the different command lines. So let me show you now. It's a basic code console. So if you pick a 3dx Max, the command line will be like this. If you pick AutoCAD, it will be like this. I have shown locally AC core console input. I mean the drawing AL application load where you give the path of the bundle. And we didn't use local edges because I'm just entering the command manually. But to automate it, we need to put that in a script file, .scr file, so that complete entire automation will be executed by this single line. If it is AutoCAD, if it is Inventor, and this is the structure. If it is a Revit, this is the structure. If it is a Max, this is the structure. Okay. Next. Activities. So we are getting an activities. If you find the activities, then we will just push it. We will update it. If you think that activity is changed, we'll update it. In this code, we are doing that. It will just get the activities different for this account. And now here we are creating the activity spec. Once we create an activity, when you create an activity, you need to do two things subsequently. One is creating an alias and creating a version. So let's understand what are aliases and versions. Aliases and versions are important for activities and bundles. So alias is the English meaning is other name. So I just said that activity can have multiple versions, right? How do you identify? How do you have an activity which will does the same job, but you want to distinguish? So then you can name an activity with an alias like dev, prod, test, anything based on your based on the level or based on the progress of the activity. If you're not published, if the activity is not fully production level, then you can give an alias as the dev. And once the activity matches to production, you can give another alias as a production. Now each activity alias will have version. You can have up to 100 versions for the same activity. These versions will have different sets of a code. So for each alias, there will be one version will be matched to it. Suppose dev may have version 1, prod may have version 10. So design automation will only understand alias of the activity. So it will that's why you need a qualified name which has a nickname, activity name plus alias. So when design automation sees this qualified name, it will know which version to pick, because alias, we have configured version in the alias. Okay, we have created an activity alias, and if you are not changing the activity alias, by default the version would be 1. So we have created an activities here. Then next, and now let's again run this. Launch program. So localhost. So configure, update parameter. Now select the engine. Autocad 24.1, create. Okay, we have created an activity. So this information you're getting it right. So this information, okay, our bundle has been created. Activity has also created. So this information is getting because of we are using a WebSocket. Whatever the design automation service will update us, whatever the design automation will update us, that from server we are broadcasting to client. So this information is not coming from design automation service, but it's coming from our own server. So look at F12. Okay, there is no console error. Okay, we'll come back here and see the client is connected. You can now pick the activity from here. Okay, now let's close. Now let's stop debugger. Now come back. Now next is the execute the work item. So activity will have set of parameters. Work item will have set of arguments. I said that the relation between activity and work item is the function definition of function call. So a function to call a particular function, the arguments should match. So the number of parameters in activity should be in sync with the number of arguments in the work item. So if there are two parameters in activity, there should be two arguments of equal name. Then only work item can easily call that activity, or else work item will not find that activity and will get an error. As I said, the relation between activity can be thought of function to function. The activity specifies the app bundles to use, which in turn specify the engine to use. The work item is then called to execute those. So work item calls the activity refers to the engine. So this engine will execute on the inputs that argument has provided to the activity. In this tutorial, the work item will specify an input URL, a JSON data, and location placeholder storage location for the output drawing. So let's go open this. Again, just copy this. Come here. Select this. So let's understand. Now the work item. So this is the endpoint that it will be listening. Okay, there is a question. Let me answer. Okay, sorry for that. There was a question on related to design automation for work shared Revit models. So, okay, coming back, design automation now in this work item will be uploading a single input file that is coming from local disk. That's why we are using Multer. This library will allows us to upload a file. The next, when we upload a file from local disk, we need to put it in some storage. So here we are using Forge OSS, Object Storage Services. So we need to create a bucket and we need to upload that drawing file which is coming from the disk. And we need to prepare the work item data. Now let's see. Here we are creating the bucket and we are creating a object key and we are uploading that file to that object to OSS. That's one part. So now that will give us an URL of that OSS. We'll be using that URL as input file argument. So we have constructed an argument URL and bucket key and object key. And we are also giving the authorization. As I said, the design automation cannot reach to your server if you have an authorization. So you need to send those authorizations to us so that we will use that authorization to access the file. The same thing we are doing this OSS. The file is in OSS and it's not publicly available. So to access that file, we need an authorization. So we are sending this object to design automation. And next is input JSON. Width parameter and height parameter entered by the user on the web interface. Those are sent as this protocol. If you look at data application.json, this is a protocol. This JSON object will be sent as JSON application protocol. So when design automation sees this protocol, data protocol, it will be downloaded as a JSON file. That's why we're mentioning data is coming as a JSON file. If you write data as text, these values will be downloaded as a text file. But we want these values to be downloaded as JSON file. That's why we're saying data protocol is application / JSON. This is a MIME, and we are sending the data as a JSON format. This sort of sending the data is recommended only if JSON data is less. That is less than 16 KB, I would say, because we have a limitation of work item payload should not be more than 16 KB. But if I have a very big JSON file, and this is not the right approach to send, it's better to send like a URL. Put the JSON file in some storage and get that link of that file, and you need to pass that as an input. For shorter, for smaller object size, you can use a data application JSON. In the next is output file. So for output also we need to create a object key. And now what we are doing is, instead of sending authorization, we are making it as signed, so that we can avoid authorization. Signed as a signed URL has a it comes with an expiry. By default it is a 60 second. By default it's a 60 minutes. So the URL will get expired after 60 minutes. So we are sending a publicly signed URL so that design automation, without any authorization, it can just upload the file, put the file into that placeholder. Now this is what we are doing. We are creating signed URL. Okay, we got the signed URL. And the output file argument, we are passing the signed URL. Yeah, we don't require authorization. But since the file is DWG, we are just passing an octet string. Even this is not required. Design automation will take care of it. It's smart enough to find out the MIME of the file, and it will use the right MIME. But if you are giving it, it's fine, well and good. Make sure you always should give the put as a verb for OSS, not post. It's a put. Now this is a very interesting bit. A work item has a callback URL, as I said, right? The progress of the work item can be captured in a callback URL. So here we are constructing a callback based on your webhook URL, the one with webhook URL which is running here. This will go here and followed by an endpoint. Design automation will send its update or feedback or progress. It will send to this endpoint, and this endpoint has some query parameters. If you look at this, it has a browser connection ID. This browser connection ID is required to establish a connection between the server and client with WebSocket. That is what the browser connection ID, and output file name. And since you're sending, since you want to send a file, you can also send the output file name, which can be downloaded by the client side. So that's why we're sending the name of the output, and we are also getting the input file name. So now where we are listening to this callback URL, this design automation will send to this, and if you look at callback URL here, So let me this is the callback URL. Okay, let me see here. Start the work item. Oh, okay, here is on callback. Now we have defined the callback, but we need an endpoint which will listen. Listen automation will send a request to that URL, but we need some router that will keep listening to the request. So here is that. After this, when the work item is done, Listen automation will call back our app using the Ngrok forwarding URL. This function will handle it and push a notification to the client. Correct. This is what we are doing it. So come back here. So this is a callback that gets triggered. Let me put a breakpoint. So you now we need to have something called to delete the account or clear the account. This is the last one, but not the least. So if you want to clean the account, we have created a routing endpoint for that as well. Okay, this will be helpful for debugging. I think we are good to go, and let's run and download. So let me copy the sample file. So you can, I'm sharing this in the chat. You can use any of the sample. If you are following with me with AutoCAD, you can use this file. But if you're using Revit or Inventor, then you may go with the relevant files. I have shared it here. So let's execute this. So I already configured it. That's why activities popped up. Give some values 30, 60, 40 something, and choose a file. I have already have it my end, so I'm using that AutoCAD sample. And so let me put a breakpoint here so that you'll understand when the design automation call, you will get an endpoint. So start the work item. Fail to upload the file. Why? What I'm missing? So what's happening? Okay, let me download that. Download that. Let me give another try. Okay, upload. Okay. So we can debug this. We got a request. We got request and activity. So market item data is there. Okay. With 16 activity name. Routes. Okay, it's on the server. What's happening here? Oh, did the bucket key? But I'm using the correct only, right? Give pardon me, I think let me figure it out. here while uploading this, make it a bucket key input file name OS. Let's create read string. I think we need to fix this. I think there was some changes in the SDK bucket. I don't know whether chunk alone must have type of string instead of why upload object. Let's see. GitHub need to use Okay, it is not different. Something is wrong with the way we upload. It says the drawing file is not. Why it's coming like this? So do we need a buffer? Can't we use data list? Why am I missing the data? Let me run this. I'm getting a failed instructions. Why? Because the drawing upload is wrong, incorrect. I think we are doing something classical mistake. Uploading the object. This requires. Okay, guys, it's success now. I think there is a problem with read file stream. I don't know where is this code. Come back. Read file stream. The problem is with this. So what I did is using without this, I have replaced with this get file buffer. I'll copy this and here I can use this. It's completed. I'm sorry. I think there is a problem. I don't know with my environment or not. Are you able to run at your end? So for me, I'm stuck here. Where is this? Here, create read string. How do we use read string? I don't know. So instead of this, this upload object takes a buffer or string we need, but not stream. So, but read stream is giving, it's not working at my end. This is not working. So what I did is, we can do a little better for this, is to let's try, should we try data if is let me try this something. Let content stream to if is read. Okay. So let me run this again. $70, $80, choose file. Okay, where we stopped. So play. This is coming as an error. If it's not defined, yeah, of course. If it's not defined, whom I'm kidding. I think we almost ran out of time. Damn. Yeah, it's your turn. You can take your time. I'll be here for another half an hour, another 10-20 minutes. Let me know if you have any more questions. Let me write 40, 60, 5. Autocad sample. Okay. We got content stream. Oh, super. This worked. Okay, it worked. So because of that, we need to use this. Yeah, you can use this. Okay. Let me know if you're also having the same problem. My Node version is little old. Maybe I have to update it 14. So when that could be the problem. You can see that callback is getting called. If you don't have any questions, I'm pausing. Okay, it's your turn. It's your last chance to submit any questions if you have. I'm pausing the recording. Okay, bye-bye. Have a great time. Good evening, good night, good morning, good afternoon, wherever you are. Stay safe, stay healthy. Happy coding. Bye-bye.